So continue for these questions. Your function h given, state the continuity of your h. Find all the asymptote and sketch the graph. So firstly, we want to find the continuity, means we want to find the domain of the graph. So domain of the graph for this function, it will fall on the characteristic of the surd and the characteristic at denominator, right? So under the surd for domain, it has to greater equals to 0. But at the same time, this under the surd is at position of denominator. So denominator cannot equal to 0. So therefore, they only can greater than 0. So under the surd, that one 9x squared minus 1 greater than 0. We solve all these quadratic inequalities, factorize, and then we draw the graph to find the x. More than 0 means this region. So the domain of the function is negative infinity until negative 1/3, not included 1/3 until infinity. So we answer the first question first. Interval of continuity of function hx is Then we continue for the second part, finding all the asymptote. When you want to find for vertical asymptote, we search for the place where the function undefined. Then we do the limit and calculate and see whether it equals to infinity or not. If infinity means that point is asymptote. Alright. So we continue for second part. The function undefined. So where's the function undefined? When your denominator equals to 0. When your 9x squared minus 1 equals to 0. So same also to solve here, quadratic. So we have two values of x. So these two values of x may be asymptote. We have to calculate and see whether the graph going infinity or not. Alright, so we start calculate limit x approaches negative 3 from the left hand side of the function. Do we need to do limit approaches negative 3 from the right hand side? Do we need to do this? Look at our domain here. Our domain only happen less than negative 1/3. So we can approaches negative 1/3 from the left hand side. But you approaches negative from the right hand side, the function is undefined. Not exist. It's not in the domain. They don't have graph there. So for this part, is undefined. Memang tak wujud bahagian graph tu. So sepatutnya tak kira pun tak apa. So we just want to know the graph when we approaches x here, is it going infinity or not? So when your graph approaches means your graph have to occur first. It have to define first. It have to in the domain first. When the graph is not in the domain, there won't have any graph there. So how you calculate this also you can't get. Alright. So we just analyze it from -3 from the left hand side. Alright, so limit approaches 1/3 from the left hand side. What do you think? In the domain or not the function? One over 3 from the left hand side in the domain or not? Where's your domain of the graph? Your domain of the graph only happen -1/3, 1/3, this side and this side. So when you're doing limit x approaches -3 from the left hand side, got function or not? Yes. In the domain left hand side. When x approaches -1/3 from the right hand side, in the domain or not? The function in the domain or not? No. So when it approaches function 1/3 from the left hand side, so this side also undefined. It's not in the domain the graph. But when your limit approaches 1/3 from the right hand side, got or not? Yeah, got graph. So we want to see is it happen an asymptote here. Alright, so how we evaluate this? So we try to substitute first, right? So when we substitute this inside here, we get -2 over 0. It is infinity. Positively or negatively? We test with x from left hand side. So -0.33 left hand side, a bit left hand side. So -0.334. Test value -0.34. What happened to this? Approaches 0 positively or negatively? Just press in your calculator for this cert 9x squared minus 1. You want to see this 0 point something is positive or negative? Positive. Is it? So negative over something positive, it gives us negative infinity. So means that at x equals to -1/3, it happened asymptote lah. Your graph going infinity, going negative infinity, going down. Alright. So for this side, we substitute 1/3 inside. What happened? 0, 0. If the case 0, 0, it is IDF. So means that we cannot simplify yet. We cannot get yet. We cannot calculate, evaluate it yet. So in the case of IDF, what should we do? We have to simplify the function, right? So what function do you have here? Surd function. Surd function. So you have to rationalize your surd function. It's not conjugate, this surd only one, so you rationalize your surd function. How you rationalize the surd function? Time with itself. Not conjugate. Conjugate is surd A minus surd B, then only you have conjugate surd A plus surd B. So if your surd only happen itself, when you want to rationalize, you just time with itself. Time with just 9x squared minus 1. Surd 9x squared minus 1. So that's the meaning of rationalize the surd. Maksudnya nak hilangkan surd dia. So after you rationalize it, you get 9x squared minus 1. Not yet simplified, right? Yet? Not yet. So we still can go simplify. what can do? Factorize. For the quadratic at denominator 9x squared minus 1, it can be factorized it as 3x minus 1, 3x plus 1. And you can notice that this IDF form can be simplified, can be cancelled. Then we substitute again and see. Denominator 2, numerator 0, 0 over 2, 0. So what's your vertical asymptote? Only x equals to negative 1 over 3 is vertical asymptote. So only 1. So this one approaches a point. When it approaches a point of value, means you won't have the characteristic you're going with asymptote. Echo dia tak akan pergi seiring serata dengan dia. Dia akan approaches a value. So it will have a asymptote at x equals to 1 over 3. Alright. Okay, so proceed. Another asymptote. Horizontal asymptote. How we found our horizontal asymptote? We need to calculate limit x approaches negative infinity and limit approaches positive infinity for the function. So as we put in infinity, this IDF, right? It is IDF for the infinity over infinity. How we simplify this? We'll divide by the x, right? But following third. So for the third form, we are going to divide x squared. For the numerator part that without x, without third, divide by negative x. So don't forget that when you divide by third x squared, it is equivalent to modulus of x. When you simplify, it can be positive, it can be negative. So when it approaches your x from negative infinity, means it is less than 0. The simplest form of the x is negative x. So here we have negative 3 plus 1 over x over square root 9 minus 1 over x squared. Try to evaluate again. Substitute infinity. 1 over infinity, 0. So lastly, negative 1. Then we proceed for limit. Finding limit approaches positive infinity. Same case happen here, IDF, right? You put in infinity. You put in here, substitute in 9 squared, x squared, infinity over infinity. So you need to simplify, divide following the third. priority go to surds, we have two cases. If you're picking polynomial, we divide by the highest power. But if you have surd, you have to follow the surd form. So under the surd, you are dividing with x squared. So for numerator part, you are dividing with x, yx. Because your x is approaches infinity, means more than 0. The simplest form of the square root of x squared is x only. So when we substitute infinity, 1 over infinity, substitute here 0. Under the square root, also 0. So you get 1. So when we calculate limit infinity, the result here represents horizontal asymptote. So we have two horizontal asymptote, which is y equals to -1 and y equals to 1. They are horizontal asymptote. So lastly, we're going to draw our graph. Take notes, all the asymptote we label first. 1 vertical asymptote, 2 horizontal asymptote. With the result later we see the graph. Any intersection will be happen here. Just look at any intersection when x equals to 0, x equals to 0, in between here, no graph, right? So we don't have y-intercept. So do we have x-intercept? When x equals to 0, when y equals to 0, it might be, correct? So we find x-intercept when y equals to 0, so multiply up your denominator, x only equals to 1 over 3. So x at 1 over 3, you're having your intercept. Alright, so we label from the first result, we found that x negative 1 over 3 is vertical asymptote. We take note of our asymptote first. So once you draw together with label, and horizontal asymptote happen at y equals to 1, here, and y equals to -1. Okay, so where the graph approaching, and our intercept, we read our intercept 1 over 3. So from the beginning, the domain for less than -1 over 3 and more than 1 over 3. So from the beginning, you know that this part having graph, having function. After 1 over 3 here also having function. In the middle, in the between -3 until 1 over 3, got function or not? Don't have. No graph. Function not defined means no graph. Not in the domain means no graph. Alright. Then, secondly, when you read limit approaches -3 from left hand side, function going negative infinity. So when you near to negative 1 over 3 from left hand side, your function going down. Correct? Negative infinity, function going down, right? When you x approaches negative 1 over 3, your function is negative infinity. Means your asymptote happened here. Alright, then other than that, we don't have already. Other than that, we don't have asymptote already. Vertical asymptote, we don't have already. So how about horizontal asymptote? When your x going negative infinity, approaches negative infinity, your function approaches negative 1. Means, bila you pergi sekiri-kiri yang boleh, you punya function menghampiri negative 1. So up here or here? So we already noticed you have one side here. So of course the curve will be. So this is the meaning when you're going. When your x approaches negative infinity, so your function approaches negative 1. So going negative infinity, your graph menghampiri negative 1. So done this part. So in the domain, this part got graph, right? So this part done. Another part, what's your domain? After 1 over 3, right? So this part, after 1 over 3. So what happened to our function? Read again. When your limit approaches positive infinity, it will be approaches 1. So it's having a here. It may be here, it may be here. Right? Okay. So what happened to our intercept? Intercept also happened at 1 over 3. So 1 over 3 included or not? Our function domain start after 1 over 3. Your intercept at 1 over 3. So at this point, included or not? At this point, included or not? No lah. At this point, included or not? No. And what you read? What do you read from this result? When your limit x approaches 1 over 3 from the right hand side, when it approaches here 1 over 3 from the right hand side, where the graph going? The graph going to 0. So exactly at this point. Exactly on this point. Nearly 0. But not included. So empty circle. Alright? So empty circle. Or coordinate x 1 over 3. And then when you're going positive infinity for the right hand side, the graph approaches 1. Then make sure our graph label everything. So what is your function? Our function is equals to 3x minus 1 over square root 12. Find some place that you can label your function.